Alright, so I'm gonna do a short, hopefully, do a short video here to review what I've done so far in my presentations, what they're here for. Um, these presentations aren't really designed to be um, the ultimate guide as to the absolute best practice when porting applications over to the Haiku, and what the full process is and what a porter is supposed to do from start to finish. I haven't accomplished that at all. So what I really don't want to end up doing is misleading anybody. I want to get people started, but I guess in this presentation I'm going to go over in theory what's supposed to be done. There are some things, and what the big picture is. Why am I trying to compile applications that a lot of people, most people have never even heard of, or if they look, in their Linux installation, they might find, oh, there's get text. I never knew I even had that. So what's going on? Why am I doing this for Haiku? Why am I not using Haiku Porter? Do I even have a good reason not to use Haiku Porter? Probably not. So let's just start from the top. So, and I'm kind of going into some of the content of Martin Brown's book from 1998. Don't have it here in front of me, but at least the part of the book that I have picked up and understand so far, and some of the things I kind of knew in little bits and pieces, but it wasn't really in a concise message. So maybe eventually I'll get to the point where I'm doing these videos and I'm good enough at this, and things are routine, that I'll just make a patch and I'll just submit it to Haiku ports. There's a lot of things that I need to learn to be able to do bigger, better things, I guess. All right, stop all this. Okay, let's start with what the big picture is. Okay, so an application, like, ultimately the goal is to be able to compile applications that people actually use, like LibreOffice, Firefox, things of that nature. Have them working in Haiku. As a side note, the chances of me accomplishing that anytime soon is very slim. I'm not at all an experienced programmer. I'm just starting by making changes to these files to get what looks like a ported application done. That is, it'll compile. I'm just barely starting to understand what's going on in source code. Let's back up again. Programs are made out of something called source code. Most of these programs are written in the C language, and most the programs that are like Firefox can't run on their own. They need other programs that are called dependencies that Firefox relies on to be able to function properly itself. So the people that made Firefox decided that they would use other programs to do functions they wanted Firefox to do, such as to save them time. If OpenSSH, for example, or SSL, or OpenSSL, is able to supply Firefox with SSL, with secure encrypted connections on the web, they only write code to integrate OpenSSL into it. And there are a number of small things, like perhaps XML cat manager ultimately needs to be in. It's like a house of cards. So when you're building Firefox, Firefox is at the top, and then you have some apps down here, and these apps rely on other applications, and these apps, and as you go down the tree, they become more obscure until it's like XML cat manager, all right, get text, all right. All right. Haikuos is what's called POSIX compliant. POSIX is a subset of standards that, as I gather, just basically are standards that say are if an operating system is if an operating system is POSIX compliant, it's able to handle certain kernel calls, and it has certain header files, certain pieces of C code that are already in the operating system and available to be used. So getting back to Firefox, we have this giant house of cards. First of all, we have the programs themselves. So Firefox depends on these programs, which depend on some more programs, which depend on more. I don't know the total list of dependencies for Firefox, but it could be 30 to 40 different dependencies as a guess, right? Okay. Then these programs, some of the code that makes up these programs are in the header files that are a part of the POSIX standard. So, getting back to what I was saying, so there's Unix is one standard. If an operating system conforms to a set of standards that the open group has created as the Unix definition as of today, and if the operating system complies with those standards, are very broad, it has the right to call itself Unix. Okay. A subset of those standards, another smaller set of standards that seem to fit in there. I mean, I can't certify it for exactly. Every Unix must be POSIX. I have to look it up, and there'd be so many things for me to look up. I'd have this stunted. It's already stunted. I'm not doing very well. BEOS is POSIX compliant, so it's got some Unix compatibility going on, basically. Part of this, it's called POSIX, and part of this POSIX compliance includes the fact that, and I'm saying BEOS. I'm going to use BEOS and Haiku interchangeably because they've done such a beautiful job of implementing the BEOS that I just don't even think about. Oh yeah, it's BEOS. Yeah. Anyway, Haiku, BEOS, they both have in general POSIX compliance, which includes some pre-written C code that all these little programs that make up the dependency of Firefox can use. So these things also depend upon the system. But then there's also differences between all these different systems. And so going from a Unix to a POSIX, there are going to be some difficulties, but it's not a showstopper. The BEOS actually has two different sets of APIs it can use. And what I'm doing is I'm dealing with the POSIX APIs, and APIs, I don't even remember what that stands for. I think it's, I don't know. I'd have to look that up. But basically, when a program runs, it sends signals to the kernel, and the kernel responds back. Those are called APIs. So for a program to run inside an operating system correctly, they need to, the program needs to speak the language that the kernel and the other parts of the operating system speak, and they need to be able to talk to each other, otherwise the program won't run, basically, to kind of use an analogy there with language. So, bottom line, let's break this down. Okay, so what I'm doing is I'm down here right now. I'm trying to work my way up, maybe to Firefox, or maybe to Thunderbird, or maybe to some other things that people want to use. I'm very far away from that. While I'm doing these programs, um, I'm taking the source code that has been made for, probably for Linux, but other Unixes, and things that are more Unix compliant than just POSIX compliant, and I'm putting it into the BOS and putting it into this mostly Unix compliant environment, and I'm using the tools that turn the source code, because people will put their source code. A program is written in a programming language, and that programming language has to be compiled to be turned into a binary file that could actually run in the operating system. What usually happens is, like in Linux or BUS2 or Haiku, so many different factors, getting confused here, and I'm a little tired, but people will download source code, and then they'll go through the compilation process. So what the compilation process is there's, of the tools that I understand, there are two basic sets of tools, perhaps even three. The first tool is like the configure tool, the configure stage. What it does is there's a program installed on the operating system that you're trying to compile the application for, and there's some kind of configure process. There's some program in the background that when you run configure, and this is actually created by the people that make the software, the configure program will check your system to see if you have what you need to compile the program, and the end result usually is the creation of something called a make file. The next step is to use a program called make that'll read this make file like it's a set of instructions to turn the source code into a binary code program. Once the program is compiled, there are two other things to do that are ancillary to that. The program could, after it's made, the program could actually be run, but to make it more useful, it's good to install the program on the system and also to package it so other systems could actually use it as well. So that's the second step, is called packaging, and the first step I mentioned there is installing. So, review. Haiku and or BUS has enough similarities to Linux when it comes to, or other Unixes like FreeBSD or NetBSD. So when it comes to attempting to download and compile source code and turn it into programs that you want to run, you have a decent shot of doing that. But there are some differences, and so some changes inevitably will probably have to be made. In both Linux, Unix, and NetBSD, and all these different operating systems, they mostly use what's called a shared library concept. So, and shared components is a better way to put it, concept. So Firefox probably relies on 40 to 50 other applications that need to be compiled before it'll even run. But some of the parts that Firefox relies on is also relied on by other programs. So the porting process for something like Firefox to get Firefox compiled and working in Haiku doesn't involve just compiling a program in general. It involves getting all the dependencies done and ready, and then moving from there up to the next, up to what you're ultimately shooting for. Meanwhile, while you're building these dependencies, you're enabling yourself to install other apps that have smaller subsets of dependencies. You're getting yourself closer to be able to do that. So it's a big, I don't know, to get an idea, the tool that I'm using called Package Source, I would gather has at least 10,000 dependencies and final programs that can be compiled. Some are obscure, some are used all the time. In an average Linux installation, there could be 3,000 to 4,000 packages installed on a desktop user's system. That includes dependencies and the final product. So anyway, so putting it all together, my goal is, and I'm also using a tool set that automates, is another aspect to it. I'm using a tool set that automates the download of all these different packages, because they're different groups all over the place, all over the world. You know, XML cat manager may have been made someone in Germany, and then gettext may have been made by someone over in Japan. You know, I'm just making things up, but you know how it gets. And so instead of having to search the web and find these things, Package Source will download these things in an automated way, and in some cases make the job of porting the app over to Haiku easier. At least for me. Okay, now, so we put it all together. So we have a tool set that'll automate the acquisition of source code, and will make and automate the compilation process, and have a way to add patches to the source code, the differences that are necessary between one operating system and another, and or fixes to the source code are called patches. And the idea is for me to try to create as many base packages as I can to work up to larger packages people actually want to use. And what I have to do is take that source code that's been downloaded and configure it, compile it, install it, and package it. And so if there be times I'll cheat, if it's already been compiled and packaged, I could force an installation in Package Source. I can move on to the next thing if I can't figure out how to get one of these base dependencies to work, like OpenSSL was one and Python was one. But over time, I hope to go back and actually know how to actually do it, whether it's in Package Source or in Haiku Porter or just by source code. And I'm trying to document this as I go so people can see what the learning process is. What I was thinking when I was trying to figure stuff out. And I can end up, like with the XML care set, cat manager, I can end up hypothesizing things that aren't even true. For a while there, I was hypothesizing that some of the headers weren't being read properly, but wasn't the case at all. It happened to be an if-then statement that was messing up the logic. He was doing either read this header file over here or use these statements below, but none of them really worked right. So I've been trying to sort out in my mind what exactly I should do. And for the sake of brevity, because I have such a long journey to go on, not for the sake of brevity, but for the sake of my own time that I can put into this, I'm just going to move on. I'm going to do a presentation for everything that I've solved. And eventually I do get to the right answer with XML care set. That's like in the last 5 minutes, basically. All I had to do is just change one file, just delete 2 or 3 lines, basically, and it worked. So when you watch my videos, watch the whole thing. Now, for experienced users that halfway through the whole thing, they know this couldn't be right or whatever, Good news is you can scroll forward to the end and see how I actually did it. Now, if I didn't do it right, let me know. If you have a better answer, let me know. The ones I haven't solved, let me know. I'm going to try to give as much feedback as I can. I'm going to try to consult Haiku ports as often as I can. And hopefully over time I'll get to the point where I just know what I'm doing. And in some cases you can't. Some cases you have to use a scientific method to figure out what exactly is going wrong, because the code base is so big. So like let's go back to XML Cat Manager. Eventually I thought about when I looked at the make file before I made the video, I thought about it and go, it's picking up this then, but I still wasn't quite sure. I had to do more things. I had to do more procedures to figure out whether, because I don't know. And right now I'm convinced that the header files, but at the time I wasn't convinced that all the header files were being read. And so I basically, by process of elimination, I first brainstormed. I thought, well, what are all the reasons that this thing could be going wrong? Oh, it could be okay, so the header files might be pulling the definitions in. That's one possibility. It could be that this definition is being passed on to the C from the second, all these, it was basically, something was going on with the headers. And then, but it didn't seem right. The logic contradicted itself, and so I kept going. I kept okay. Let me see if it still works if I get rid of this thing. If I don't add the ctags header, ctags.h file. Maybe if I don't put that over here in the local area, let's see if it still works. Oh, it still does. Okay, and then finally it got to the point where it was like, okay, there's only one file that I've had to pull, and it seems to be not being used because of this conditional, so I just changed the file and then it worked. So it's just what porting is in part is gathering, first attempting to compile, seeing where it errors, investigating it, brainstorming all the causes of what could have made it go wrong, and then trying all these different ideas until it works, and then seeing that if you take any of these little things that you've tried away, if it still works, and then finally getting down to what it actually was. And then once you're there, you can move on. So there's going to be some times where I'm going to have to hypothesize. So it's, in some ways it's important, or it could be, have some value just to see how I get to the final result that I get to. So yeah, I'm going to leave things up, but I wish I had shorter versions of this to say, okay, if you're trying to do XML Cat Manager, just do this, without all the stuff that I went through to get to the final result, if that's all you're looking for. Or all you need, if you know this other stuff, if you're more experienced. Maybe I'll make shorter edited versions of these things. Alright, so that's it and then today I'm gonna redo Mutt and the links program. I'm gonna go over what's working, what isn't working, and things that I've found also in the next video I do. Then I'm gonna do Mutt and links, and then I'm gonna move on to Emacs, because I'm actually more or less ready to do that. I'm more ready to do that than I am ready to do GCC or Bison, which is kind of where I'm stuck at now. And once I do GCC and Bison, I may be able to do more interesting programs. Or maybe I'll have more dependencies to work through. So there you are.